we are surrounded by many seemingly simple things. But do you know how they're made? In the world, there is a large number of modern enterprises manufacturing various goods that are a part of our everyday life. In this video, we will tell you how condoms are made, where chocolate is born, how tires of gigantic size are manufactured, and how giant wind turbines are created. Don't forget to subscribe to our channel and like this video. Ready to learn something new? Let's go! Chocolate. It's not just delicious treats, but a complex product. There are thousands of varieties of this dessert, from classic chocolate bars to candies with different fillings. This dessert is loved all over the world. Have you ever wondered, though, how it's made? Real tasty chocolate is made from quality cocoa beans. The basis for our favorite chocolates is mainly born in African countries, such as Ivory Coast, Ghana, Nigeria, and Cameroon. Nearly 70% of all cocoa beans used in confectionery production come from these four countries. Cocoa beans grow on special plantations. Dozens of workers ensure that the cocoa seedlings have enough water and are protected from pests. Periodically, the pods are cut and the beans are carefully extracted to determine their ripeness. To avoid damaging the beans, the pods are tapped with a special shovel before being carefully cut open. Since the trees are grown in the tropics, where the climate hardly changes throughout the year, the beans are harvested several times a year because the fruits ripen unevenly. So there is always work on the plantation. Most of the processes are done manually. When the pods are sufficiently ripe, they're harvested, and the beans are carefully extracted to avoid damaging them. All the beans that are not ripe enough or have begun to sprout are rejected. They shouldn't end up with the rest. Quality chocolate can only be made from quality and selected beans. If you taste raw cocoa beans, their taste will pleasantly surprise you. They are bitter and astringent and don't resemble the taste of the candies we're used to. Some varieties have a sour taste. To get a pleasant taste, they need to be processed correctly. Cocoa beans are set aside for fermentation. Here's what it looks like on most plantations. Large boxes are filled with collected beans and covered with banana leaves and bags to maintain temperature. This is how fermentation begins. During this process, natural sugars in the beans turn into acid, which helps develop the characteristic taste and aroma of chocolate. From time to time, a specialist mixes the beans and aerates them. When the beans are loaded into boxes, they have more of a fruity smell. During fermentation, this smell changes to an alcoholic one, and then it resembles the smell of vinegar. It's important to not over-ferment the beans as they can start to rot, so specialists check from time to time. To stop the fermentation process, the beans need to be well dried. They are spread out in the sun and periodically raked. Special drying machines can also be used, but they are only available on modern plantations. Moreover, even there, the beans are first dried in the sun and only then sent to a special machine. After the beans have lost the necessary amount of moisture, they can be packed in bags and sent to chocolate factories. They are delivered by trucks to ports or airports to be shipped around the world by ships and planes. At the factories, bags of beans are unpacked and samples are taken to the laboratory to determine the quality and select the best recipe for the future dessert. The beans need to be roasted and cleaned. They will then be loaded into a grinding machine. The beans are ground to become a liquid. This yields two main components: cocoa butter and cocoa powder. Cocoa butter must be aged for several weeks. This significantly affects the taste of the product. And the third essential opponent of quality chocolate is sugar. Other ingredients can also be added in various proportions. For example, for a delicate and less bitter taste, milk or special substitutes are added. This is how milk chocolate is made. But which type of chocolate do you prefer? Dark or milk? Let us know down in the comments. To prevent a candy or chocolate from melting immediately in your hands, the chocolate mass needs to be tempered. Chocolate is cooled at a certain temperature and then reheated. This is necessary to stabilize the cocoa butter crystals and maintain the shiny texture and structure of the chocolate. Depending on the recipe, other components, stabilizers, and fillers are added. At large factories, the entire process is automated. The chocolate mass is poured into molds, and after that, they pass through a cooling system, which allows the product to solidify quickly. Often, large trays with molds are taken to large refrigerated rooms to expedite the process. And when the chocolate hardens, automated lines package the sweets. Quality control is then carried out at every stage of production. In addition to visual inspection, the products are weighed, tested, and tasted. Automated monitoring systems help detect any deviations. In small confectionaries, everything is done not by a machine, but by a person. The principle remains the same, but everything needs to be done manually. In such workshops, there are usually several people working. Each has their own responsible mission for preparing a base to forming candies. Decorating is quite meticulous work, but the result is well worth it. Just look at the handmade candies that come out. Confectioners use a special bag to form decorative chocolate elements on the candies. After this, the chocolate must fully solidify. This is something that may take several hours. They are placed in refrigerators to harden, but it's important to not do this too quickly so that the chocolate doesn't crack and lose its appearance. The finished products are sent for packaging. The candies are either wrapped on a special conveyor or manually packed into boxes or paper envelopes. After that, they go to the shelf of stores and confectionery counters. There is a huge assortment of condoms from various manufacturers, ultra thin with specific shapes, textured, glowing in the dark, or even in different colors. However, they are all united by the common principle of manufacturing. Before they reach us, they go through several complex stages of production and testing, which can take up to 2 weeks. It all starts with preparing a special mixture. Up to 90% of all condoms worldwide are made from latex, and it's no wonder as this material is extremely strong. It's difficult to tear or damage. Moreover, it's hypoallergenic, unlike many other materials that can be used for making condoms. Latex is made from a liquid extracted from rubber trees. It's white and resembles milk. There are entire farms in tropical countries where the base for latex products is extracted. The liquid is collected in a special container, stabilizing agents are added to prevent the liquid from thickening and losing its quality, then they are poured into large tanks that are shipped to factories around the world. Various compounds are added to the rubber liquid during production to obtain a strong and elastic material. Specialists in laboratories study the properties of the base and accurately calculate the amount of other components. This is a responsible process. The quality of the entire batch depends on it. If a mistake is made in preparing the mixture, the finished condoms won't pass the strength and quality tests, so the entire batch will be sent for disposal. First, a small trial batch is prepared, which is thoroughly checked. Only after that can a full-scale mixture be prepared into an industrial scale. The finished mixture is left in huge containers for a week to stabilize and acquire the necessary properties. During this time, all the air is released from the mixture. If it's used without waiting for a few days, the finished product won't be strong due to its microscopic holes formed by small air bubbles that haven't had time to escape. Special temperature is maintained in the containers during this time. When the mixture is ready, it's checked again and transported to the production line. Pay attention to the molds dipped into the latex mixture reservoir. Glass bulbs have the size and shape of the finished product. Some have a textured surface or a specific shape. The length of the dipping machine line is approximately 30 meters. Each bulb can be dipped in latex several times. The thickness of the condoms depends on this. So when you see the ultra-thin mark on the packaging, you'll know how they are made. After each dipping, as it moves along the conveyor, the layer of latex has time to dry. When the required number of dips is done, the line goes to a special oven for vulcanizing the latex. This helps give the material strength. If this isn't done, the condom can be easily torn by hand without much effort. However, after vulcanization, it will be difficult to damage the latex with hands or even a sharp knife. When drying is complete, the condoms need to be removed from the bulb. This is done using a water flow. They are collected in a special container. To prevent the rubber from sticking together, they need to be rinsed and coated with talcum powder. Starch mixture is often used for this purpose. This is done in special machines resembling large washing machines. In them, condoms are also cleared from possible chemical residues of production and sterilized to prevent any microfibers on the surface. After such washing, they are left for several days to fully stabilize. Then comes the important stage: testing. It's necessary to ensure the quality of the finished products. There are many different methods for this. Condoms are inflated using a compressor to enormous sizes until they burst. This helps ensure their strength and absence of weak spots that could cause tearing. Pay attention to the large sizes the condoms can be inflated to before bursting. According to international standards, safe condoms should withstand 18 liters of air. However, quality products can easily withstand up to 30 liters of air. All indicators are recorded by a special computer system, which determines the load and pressure inside. Several condoms from the batch are filled with water to check for leaks. This test can be done manually or with special machines. It's important to make sure that not a single drop of water can seep out. These condoms won't be sent to the packaging line anymore, but they help ensure that everything was done correctly and the rest of the batch has the same high quality. Random samples in the laboratory are also tested using various tests, from the strength of the cross-section to examining the structure under powerful microscopes. But if only a few condoms from the entire batch are selected for air and water testing, all products are checked on the next machine. Condoms are manually stretched over stainless steel bases. An electric current passes through them. Latex is a good dielectric that doesn't conduct electricity. A special brush checks each condom. If it detects electrical voltage, it means there's a hole. This process is similar to washing a car at a car wash. Defective condoms are automatically removed from the line and will be disposed of. This check helps ensure that no substandard products reach consumers. Usually, the packaging indicates that each condom has been checked for defects. Finally, condoms are coated with a special layer of lubricant on a silicone or water base. It's needed not only for comfortable use, but also for long-term preservation of the latex quality. A special machine rolls up the condom and sends it to the sorting and distribution line. Condoms move along the conveyor where a robotic arm places them. In small factories, this is done manually by a person who places condoms in special niches. They move to the packaging lines. The quality of the product and its shelf life also depend on the packaging. The packaging must be completely airtight, because contact with the air over a long period of time deteriorates the quality of the latex, causing it to lose its initial elasticity and strength. It is for this reason each individual package has a polyethylene layer that hermetically seals each condom. The second layer of packaging is made of foil material. It helps protect the latex from sunlight, which also negatively affects the material over time. Condoms are sealed in the package and cut with a special guillotine. Finally, they can be packed into boxes. In large enterprises, this is done by a machine, while in small factories, the task is entrusted to packagers who place the necessary quantity of condoms and usage instructions in the box. At the final stage, the packed boxes are wrapped in film for additional protection and packed into large boxes. After this, the condoms are ready for delivery to pharmacies and stores. Wind energy is one of the most promising industries in the world. To create green electricity worldwide, giant wind turbines are installed. Just a few of these can power a small town, but how are they made? Specialized factories are involved in manufacturing these giant structures. They use steel plates for this purpose. This material is an ideal solution for making wind turbines because steel has high strength, capable of withstanding enormous loads, and is inexpensive. To manufacture the base of the turbine, special machines for rolling steel plates are used. Two cylinders rotate at different speeds, allowing the metal sheet to bend. To make the cylindrical body, the steel sheet needs to be rolled several times. A worker uses special gauges to check the bending angle. A special machine then rolls the metal several times until the required shape is achieved. After this, the sheet is welded. This is just one small section of the turbine base. Dozens of them are needed. A crane lifts and moves each section, weighing tens of tons to weld them into a single structure. Since these are gigantic tubes, they need to be welded manually. Note the small person against the backdrop of the turbine base. When the sections are welded together, the welds are cleaned with a grinder. To prevent any rusting, the metal is treated with a special anti-corrosion mixture and painted both on the outside and the inside. There are special holes for attaching the sections at the edges of each such part. Manufacturing the blades is a much more complex process. First, engineers design their shape on a computer. They have a special shape that will ideally catch wind flows. Steel and other metals are not suitable for their manufacture because they would be far too heavy. The blades need to be lightweight and extremely strong to withstand their own weight or strong winds. Fiberglass and various composite metals, such as carbon fibers, are used for their production. They are extremely strong and lightweight. The blade manufacturing process resembles paper mache. Layer by layer, the turbine's base is formed. Epoxy resin is used to bond the layers together. It also adds strength to the structure. This process is almost entirely done manually, so it's important to follow diagrams and blueprints to maintain the aerodynamic properties of the blades. Once the base is ready, it is sanded and painted. All irregularities need to be removed to make the surface perfectly smooth. Note that one blade is as long as the hanger where they are manufactured. Their size is truly impressive. This 107-meter turbine was made for another wind turbine in France. All workers and their families lined up along it. That's 205 people. How tiny they are compared to the construction element. This is just one of 3 blades made at the factory. The diameter of the assembled wind turbine is approximately 220 meters. Before they leave the production hangar, they must be tested though. Special machines that shake the blades simulating storm gusts of wind are used for this purpose. This helps ensure that the structure is reliable and that there are no weak spots. Thanks to the use of composite materials, the blades bend but don't break and restore their shape. If they were made of metals, they would deform and become unusable within just a few seconds of the test. Such tests can last several hours to ensure that they don't lose any of their strength, as wind turbines are expected to work for decades. To transport wind turbine parts to their destination, large trucks with trailers are required. Before a wind turbine or blade is transported, they are usually disassembled into separate parts that can be transported both safely and efficiently. This reduces the dimensions and weight of each part, making transportation much easier. However, blades cannot be disassembled, so they have to be transported whole. During this process, streets are closed off. Transporting them is quite difficult, especially at turns and road intersections. In urban conditions, this is almost an impossible task. Even on highways, various difficulties may arise. Therefore, the route is carefully planned. To make a turn and pass one blade through this intersection, it was necessary to block traffic. This must be done slowly and carefully, as the drivers of the main truck and trailer work in harmony to avoid accidents or damage to the structure. The convoy is accompanied by special vehicles with flashing lights, warning other drivers of the danger. To prepare the site for the wind turbine installation, a special trench is dug and soil is compacted. Wind turbines can weigh hundreds of tons, so it's necessary to choose the right location and prepare it well to prevent soil settlement. It is then filled with concrete, forming a monolithic slab. A special frame is also installed. Using giant cranes, each section of the foundation is installed one by one. They are fastened inside. Workers ascend using a special shaft. Next, the power unit itself, which will generate electricity, is installed. Mounts for the blades are installed on top. Working at such heights is dangerous. 2 cranes lift the blades, which are then attached to the rotor. Sometimes the wind turbine is assembled on the ground and then all 3 blades are lifted up at once to be attached to the generator. This depends technically on the complexity of the work. Would you dare to climb to the top of a wind turbine? Manufacturing rubber tires for cars is a complex process. Various types of rubber, both synthetic and natural, are used in production. Raw materials such as rubber, carbon black, oils, sulfur, and other additives are mixed together using special machines and drums to create a homogeneous rubber mixture. From this rubber mixture, sheets of the required thickness are produced. These rubber sheets are used to create the tire base and sidewalls. Using special press molds shaped like ring bases, tires of the required size are shaped and formed. For greater reliability and strength, reinforcement is used. A special metal mesh becomes the basis for the future tire. Afterwards, the rubber undergoes vulcanization, which adds maximum strength to it. At the final stage, the tire undergoes quality control, where it is checked for defects, dimensions, thickness, as well as any resistance to pressure and wear. After successful quality control, the tire is ready for packaging and shipment to warehouses and sale to consumers. However, in the production of tires for airplanes, more complex processes and more thorough quality control are used because, well, the lives of hundreds of people depend on airplane tires. Therefore, their production involves many complex technical processes. Aircraft tires are typically manufactured using the same technologies and at the same plants as tires for racing cars. They must be as strong as possible. Although aircraft tires are only used for a few minutes during takeoffs and landings, they are subjected to enormous loads during this time. The first step in making aircraft tires is selecting special materials that meet aviation standards. Typically, high-strength rubbers and special composite materials are used to provide the necessary strength, elasticity, and wear resistance. Special pressures and molds are used to shape the tires. The material mixtures are subjected to high pressure and temperature, allowing them to take on a required shape and structure. Additionally, aircraft tires have a specific thread design that ensures the necessary traction with the runway surface. The tires undergo vulcanization, a process of increasing temperature and pressure that helps create strong chemical bonds in the material structure and increases its resistance to loads and temperature fluctuations. Aircraft tires are rigorously tested and checked using dozens of different tests and special equipment. Mistakes can cost people's health and lives. Therefore, there are many checks and quality controls at such plants. For military jet aircraft, tires need to be even stronger as they must withstand the tremendous temperatures generated during takeoff and landing. Therefore, aviation rubber must withstand extremely high temperatures. The process of manufacturing large tires is similar to that of regular tires, but specific large-size machines are used. Similar to regular tires, it's necessary to produce rubber sheets of the required thickness for large tires. These sheets will then be used to form the giant tires. Many processes are carried out manually or under the careful supervision of specialists who manually apply the reinforced base layer and inspect the tire quality. Each new product is checked for defects. It's worth noting that the size of these tires is twice as large as a person examining them. A special mechanism rotates the tire while it's carefully inspected and felt. At one stage of the inspection, the inspector even needs to enter the rotating tire, resembling a hamster wheel. They check the distance between the edges and inspect the internal part using a flashlight. Once the inspection process is complete, a lift transports the tire to the warehouse and prepares it and dozens of others for transportation. Many modern factories use robotic manipulators in the production process. These robots handle, cut, and inspect rubber sheets on conveyor lines. However, even here, manual work cannot be avoided. In addition to visual inspection, quality experts use special laboratory equipment to determine tire quality and strength. For large batches, several samples are selected for testing and thorough inspections before they are sent for sale. New giant tires are transported on special trucks. Platforms were designed to securely fix the giant tires in a vertical position. Each platform can carry up to 8 such tires. This method of transportation is more efficient because, well, lying the tires take up more space and occupy a significant portion of the road. This creates danger for other drivers and requires an escort vehicle with flashing lights to warn other drivers of the danger. The new tires are securely fastened with special fasteners. By attaching 2 additional trailers, one truck can transport up to 24 giant tires weighing tens of tons. This helps reduce transportation costs and lowers the cost of the finished product because such tires often travel thousands of kilometers to their destination. Therefore, it's no wonder that such platforms are used in tire production for dump trucks and other oversized vehicles. The entire route is carefully planned by logistics teams. The tires are loaded onto the platforms using special lifts and securely fastened. When they arrive at the destination, the complex process of installation on trucks, construction, or agricultural machinery begins. This takes a lot of time and requires special equipment. The body of the machine is lifted using powerful hydraulic jacks. The larger and heavier the equipment, the more powerful the jacks need to be. The machines are securely fixed to prevent them from shifting using blocks, and then the air is released from the chamber to remove the wheel and replace it. A new tire is brought on a truck and removed using a crane, as it can weigh several tons. This is quite dangerous, as you might imagine, so workers move to a safe distance. If such a tire bursts, it can fly off and cause some serious injuries. Any old ordinary manual tools won't help in removing the old tire. Hydraulic clamps are needed. These are used by rescuers when it's necessary to quickly extract a victim from a car whose doors are blocked due to damage in an accident. This tool helps remove the fasteners and tire. The old tire is dismantled using a lift or crane, and a new one is placed in its place. All fasteners need to be thoroughly cleaned of dirt. All parts are lubricated and put back in place. When the tire is fixed, it can be inflated using a powerful compressor. Although everything looks quite simple and fast in the video, in reality, it takes several hours and requires the work of several people. And now, what should we do with all the old leftover tires after the replacement? Well, they need to be properly disposed of, as they pose some serious environmental problems. Millions of tires end up in huge landfills every year. This pollutes the soil and groundwater, and in case of a fire at the landfill, tires can cause a real catastrophe over large areas. That's why tires have started to be actively recycled, giving them a second life. First, old rubber is cut up with powerful hydraulic guillotines. They can easily handle even large tires for trucks and special vehicles. Cutting machines work like scissors. A tire, like a cake, is sliced into pieces. The mechanism rotates the tire after each new cut. Some machines first cut large tires lengthwise to cut them into smaller pieces. By cutting large tires this way, it is much easier to transport them to specialized plants that recycle old rubber into something new. There is no need to use special vans that can only transport a few tires. By cutting tires, dozens of tons of rubber can be transported for recycling right away. What impressed you the most in this video? Go ahead and write it down in the comments section below. And don't forget to support us with a like and share this video with your friends. See you guys in the next videos.